Okay, students, so let's get started with AS level physics dynamics MCQs. Let's start with the first MCQ. This document, along with the solutions, are attached in the description below. A car of mass 850 kg is traveling in a horizontal straight line. The diagram shows two horizontal forces acting on the car in opposite directions. Perfect. One force has a magnitude of 1200 Newton and the other force has a magnitude of 600 Newton. What is the magnitude of acceleration? Very easy. First of all, we will calculate what? Resultant force. Resultant force will come out to be what? 1600 minus 1200, since both of them are acting in opposite directions. 400 Newton is your resultant force. Then we will apply F is equals to ma. Your force is 400. Your mass is 850. Acceleration will come out to be what? 0.47 ms minus 2. A is your answer. Two blocks of mass 0.2 kg and 0.5 kg are connected by a light inextensible string that passes over a frictionless pulley. Perfect. Two blocks are initially held stationary. The block of mass 0.2 kg rests on a rough horizontal surface. Okay. That means there will be a frictional force that acts here. That means there will be a frictional force that acts here. Perfect. And since they are attached to a string, there will be a tension T in the string here and there will be a tension T in the string here. Perfect. Air resistance is negligible. That means your gravitational field strength will be 9.81 ms minus 2. Perfect. When the blocks are released, there is an acceleration of 2. Perfect. When the blocks are released, there is an acceleration of 2 ms minus 2. Perfect. What is the frictional force? We have to calculate the frictional force. Okay. One thing to always remember here. This is a key point that you can write. Pulley always rotates in the direction of heavier mass. Pulley always rotates in the direction of heavier mass. Simple as that. But where is the heavier mass here? This 0.5 kg. So this pulley will rotate in this direction. And if the pulley rotates in this direction, the 0.5 kg mass will move downwards and 0.2 kg mass will move towards the right. Perfect. Now let's consider the 0.5 kg mass. Let's consider the 0.5 kg mass. What are the two forces acting on the 0.5 kg mass? One is tension and the other one will be the weight of the block. And the other one will be the weight of the block. If I have to calculate the resultant force for this 0.5 kg mass, how will I do that? Always remember the force acting in the direction of the movement. This 0.5 kg mass is moving downwards. Which force is acting in the direction of the movement? Weight. That will be placed first and then you will place the other force, that is tension. What is the value of weight for 0.5 kg mass? Let me also write a heading here that this is calculations for 0.5 kg mass. These are the calculations for 0.5 kg mass. Perfect. Your resultant force will come out to be what? Weight, that is 0.5 into 9.81 minus tension. So this comes out to be what? 0.5 into 9.81 and this will come out to be 4.905 Newton minus tension. Okay. So this is your resultant force. And we have studied a formula F is equals to ma. So let's replace this resultant force with what? Mass, that is 0.5 into the acceleration, that is 2. Perfect. What happens? 0.1 into 2 is 1 is equals to 4.05 minus tension. Tension comes out to be what? 3.905. Perfect. Now, if you observe this mass, if you observe this free body diagram, this is moving towards the right. Okay. What is the force on the right? Tension. So how will you calculate the resultant force here? One second. Let me put this key point here. How will you calculate the resultant force for the 0.2 kg mass? Resultant force is equals to what? Tension minus the frictional force. Okay. What is the tension? 3.905 minus the frictional force. Okay. What is the mass? 0.2. What is the acceleration? 2. Your frictional force comes out to be what? 3.905 minus 0.4. Your frictional force is 3.5 Newton. A is your answer. Simple. Let's further move ahead. A snooker ball has a mass of 200 grams. It hits the cushion of a snooker table and rebounds along its original path. Okay. The balls arrive at the cushion with 14 ms minus 1. Perfect. And then leaves at a speed of 7 ms minus 1. The ball and the cushion are in contact for 0.6 seconds. What is the average force exerted on the ball by the cushion? Perfect. Let's say this is your ball. Perfect. And let's say this is your ball arriving towards the wall, or you can say the cushion, with a speed of 14 ms minus 1. It leaves the cushion or the wall. You can write here wall or cushion here. It leaves the wall or cushion at a speed of 7 ms minus 1 and the time is 0.6. Can you calculate the average force? Yes. Average force is equals to change in momentum over change in time. Okay, change in momentum can be represented as what? Mass into change in velocity over change in time. Perfect. Now, always remember that whenever you are doing questions related to vectors, you can first of all mark the axes. Right side as positive, left side as negative. Okay. Here, what is your mass? 200 grams. This becomes 0.2 kg. What will be your change in velocity? Final velocity, that is 7 towards the left, minus initial velocity, that is 14 towards the right. So 7, final velocity will be what? Minus 7. Initial velocity is towards the right, it will be negative 14. Please remember, change in velocity is equals to what? Final velocity minus initial velocity. That's what I have done here, divided by 0.6. Your answer comes out to be what? 7 Newton is your answer. 7 Newton will be your answer. Please remember, change in velocity is what? Final velocity minus initial velocity. Since final velocity is acting towards the left, it will have a negative sign. Since initial velocity is acting towards the right, it will have a positive sign. Simple. Let's further move ahead. A box rests on Earth as shown. Newton's third law describes how forces of the same type act in pairs. Okay. One of the force of the pair is the weight W of the box. Which arrow represents the other force of the pair? Okay. So the pair of forces which Newton's third law refers to tells us that the two forces are equal, opposite, and they act on different objects. They act on different objects. Okay, they act on different objects. Here, a force opposite to W will be what? Either B or A. C and D can get cancelled out. A force opposite to W will be what? B or A. But B acts on the same box. In Newton's third law, we have studied that the two forces are equal opposite and they act on different objects. Only A is your remaining answer. A is the correct answer. Let's see this. A ship of mass 8.4 into 10 raised to the power of 7 kg is approaching a harbor with a speed of this. This is your initial speed. By using reverse thrust, it can maintain a total stopping force of this. Perfect. How long will it take to stop? Perfect. Your resultant force is 9,20,000 Newton. Your mass is this. What will be your deceleration? F is equals to MA 920,000 divided by the mass, that is 8.4 into 10 raised to the power of 7. Your deceleration comes out to be what? Let's calculate that. 920,000 divided by 8.4 into 10 raised to the power of 7. This deceleration comes out to be what? Negative 0.0109 ms minus 2. Perfect. This is your deceleration. Your initial velocity is this. Your initial velocity is 16.4 ms minus 1. You have to come to a stop. So your final velocity will be 0. Final velocity is 0 ms minus 1. Your deceleration is what? Negative 0.0190 ms minus 2. Can you calculate the time? Yes, V is equals to U plus 80. Perfect. U is 0. V is 0. U is 16.4. Deceleration is what? Negative 0.019. Negative 0.0109 into T. 16.4 divided by answer. Your time comes out to be Time comes out to be 1497 seconds. But you wouldn't find such an answer here. So what will you do? You will divide this by 60 to convert your answer into minutes. Your answer is 25 minutes approximately. C is your answer. Let's see this one. A device for spraying paint consists of a box with its face horizontal and vertical. One of its vertical face contains small holes. Okay. Paint is fed into the box under pressure via a vertical tube. Okay, like this. And exits through the holes as fine streams moving horizontally. Perfect. The paint is ejected at a speed of this through 400 holes, each of area this. The density of paint is this. We have to calculate the horizontal force that we exert, that the paint base horizontal force to hold the device stationary. Perfect. So first and foremost, what is the formula for force? Force is equals to change in momentum over change in time. Here I am going to do a derivation that you can utilize for multiple other questions. Force is equals to what? Mass into change in velocity over change in time. Perfect. Now from basic O levels in IGCSE physics, you might have studied that density into volume is equals to your mass. Okay. Substitute this mass here. Substitute this mass here. Density into volume. Okay. Into change in velocity over change in time. Perfect. Now, what can you break down your volume into? What can you break down your volume into? Volume can be broken down into what? Area into length over time into change in velocity. This thing is also equal to what? Velocity. So the final formula for force also becomes what? Density into area into velocity square, because this thing becomes velocity, it gets multiplied with this becomes velocity square. So this is your final formula for force. Perfect. Okay. Do you have the density here? Yes, 900. Do you have the area here? Yes, 0.4. But this is millimeter square. Okay, now always remember, whenever you are given your area in millimeter square and you want to convert it into meter square, you multiply it by 10 raised to the power of minus 6. Let's do that. 10 raised to the power of minus 6. What is the velocity? 2.5. 2.5 square. And what are the number of holes? 400. Multiply it. The total force comes out to be 0.9 Newton. B is your answer. Why have I multiplied by 400? Why have I multiplied it by 400? Because there are 400 holes in this system. So we have to multiply it by 400 to get the total force. Okay, let's see this question. A mass of 0.2 kg is suspended from the lower end of a light spring. A second mass of 0.1 kg is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium and then the thread is cut. Perfect. Immediately after the thread is cut, what is the upward acceleration of the 0.2 kg mass? Okay. What do we mean by static equilibrium? By static equilibrium, we mean that up forces is equals to down forces. If we cut this thread, what will happen? If we cut this thread, what will happen? This force, that is 0.1, the weight of this block 0.1 into 9.81, that comes out to be what? 0.1 into 9.81. This comes out to be 0.981 Newton force. Immediately as we cut this thread, this force of 0.981 Newton will vanish from the downside. Currently, in the current scenario, let's write it here, current scenario. In the current scenario, up forces are equal to down forces because you are in a static equilibrium. As soon as you cut this mass with a thread, this amount of force vanishes. So your resultant force equals to what? 0.981 Newton. Perfect. And what is your mass? Resultant force is 0.981 Newton. And you know F is equals to ma. 0.981 is equals to the mass, that is 0.2 into acceleration. 0.981 divided by 0.2 gives you your acceleration. Let's calculate that. This comes out to be 4.9. A is your answer. Okay, let's see this question. A child of mass 20 kg stands on a rough surface of sledge of mass 40 kg. The sledge can slide on a horizontal frictionless surface. One end of the rope is attached to the sledge. The rope passes around a fixed frictionless pole, and the other end of the rope is held by the child as shown. Okay, the rope is horizontal. The child pulls on the rope with a horizontal force of 12 Newton. Perfect. This causes the child and the sledge to move forward with equal acceleration towards the pole. What is the frictional force between the child and the sledge? Okay. First of all, you need to realize that friction is only acting between the child and the sledge. The frictional force is only acting between the child and the sledge. That is this thing. And what will be the other forces? There is a tension acting here, and there is a tension acting on the sledge as well. Also, according to Newton's third law, if a child is acting a force on the sledge will also act a force on the child. This will be the opposite to friction as well. Okay. So now here we can create two free body diagrams or two body equations. First of all, let's consider this child only. Let's consider this child only. Okay. Tension is acting towards the right, friction force is towards the left. 12 minus frictional force is equals to the mass of the child, that is 20 into acceleration. 12 minus 20 into acceleration is equals to your frictional force. Okay. Now let's further observe. Frictional force is towards the right, tension is towards the right. The mass of the sledge is 40 kg. So if I draw or if I apply the resultant force equations to only this sledge, then what will happen? Frictional force plus tension, that is 12, is equals to mass into acceleration. Frictional force is equals to what? 40A minus 12. You have two equations, this one and this one. Let's equate both of them. 12 minus 20A is equals to 40A minus 12. Perfect. Let's take 12 to the other side. It will become 24 is equals to 60A. 24 divided by 60 is equals to your acceleration. Your acceleration comes out to be 24 divided by 60. This is 0.4 ms minus 2. Perfect. Now place 0.4 ms minus 2 here. 20 into 0.4 is equals to your frictional force. Let's calculate that. 20 into 0.4. Yeah. 12 minus 8, your frictional force is 4 Newton. A is your answer. Simple as that. Let's further move ahead. Okay, let's see this. A car of mass 750 kg has a horizontal driving force of 2 kilonewton. Perfect. So this is 2 kilonewton. It has a forward horizontal acceleration of 2 ms minus 1. What is the resistive force x? We have to calculate x. So 2000 minus x is equals to ma. I have just applied F is equals to ma. What is your mass? 750. What is your acceleration? 2. 2000 minus 1500 is equals to your resistive force. Your resistive force comes out to be 0.5 kilonewton or 500. If I check in the marking scheme, the answer for 17 is A. Perfect. Let's see this. A constant resultant force acts on an object in the direction of the object's velocity. Perfect. Which graph shows the variation with time t of the momentum of the object? Perfect. We have to show momentum versus time graph. Perfect. So force is equals to change in momentum over change in time. Let's take time to the other side. Force is equals to change in time is equals to change in momentum. Now, since force is getting constant, what will happen? Momentum is directly proportional to time. Which graph is there for direct proportionality? Not A, not B, not D. C is your answer. Always remember, direct proportionality graphs are straight lines. Perfect. Let's further move ahead. Let's see this. The diagram shows two parachutists X and Y moving vertically downwards. Perfect. The total mass of parachute Y and his parachute is twice the total mass of parachute X. Perfect. So if this has a mass of 2m, this will have a mass of m. Perfect. The total mass of, okay. And his parachute. At this moment, the air resistance on parachute Y is twice the air resistance on parachute X. Perfect. So air resistance acting on this parachute is 2R. Air resistance acting here is AR only. Neither parachutist has reached the constant terminal velocity. Which statement describes the acceleration of Y compared with the acceleration of X? Okay. What will be the acceleration of Y compared to the acceleration of X? Both will be same. Why? Why will both be same? Can you realize the extra mass, weight minus AR is equals to MA. Weight minus AR divided by M will be your acceleration for X. Okay. Now the extra mass at point Y will generate extra weight. I agree with that with you guys. Resultant force will become what? 2W minus 2AR. Perfect. But you have an extra mass that gets also divided here. The resultant force comes out to be what? 2W minus 2AR. Now from here you might say that acceleration has increased. No. But instead of resultant force, what will you place? 2ma is equals to 2w minus ar. I have taken 2 common, 2 and 2 cancel out. Acceleration again becomes what? W minus ar divided by m. So your acceleration for x and your acceleration for y both remain same. Even though the mass has increased due to the increased air resistance, the acceleration remains same. Okay, let's see this. A ball strikes a horizontal surface with a momentum p at an angle of theta to the surface as shown. The ball rebounds with the same magnitude of momentum at an angle of theta to the surface. The ball is in contact with the surface for time t. What is the magnitude of average resultant force? Simple. You have to calculate the resultant force. Resultant force is what? Change in momentum over change in time. Perfect. Now, if you analyze, these are diagonal momentums. Let's break them down. This will be the vertical component. This will be the horizontal component. Again, this will be the horizontal component and this will be the vertical component. Okay. If you realize the horizontal momentum is staying same. What will be this horizontal momentum? P cos theta here and P cos theta here. This remains same. However, the vertical momentum P sin theta, although they seem same in magnitude, although the magnitude of vertical momentum seem same in magnitude, their direction has changed. One is acting downward, one is acting upward. Can you realize that the momentum in the horizontal direction didn't change? The momentum only in the vertical direction changed. Now, here, first of all, what will you do? You will say the upward direction is positive, downward direction is negative. Okay. What is the final momentum? P sine theta. What is the initial momentum? Yes, negative P sine theta because it is acting downwards divided by time t. What is change in momentum equal to? Final momentum minus initial momentum over time. I have placed the final momentum as P sine theta here. The initial momentum is acting downward, negative P sine theta. P sine theta, negative, negative, positive. This comes out to be 2P sine theta over T as your answer. Any options like that? D is your answer. Simple as that, nothing complicated here. A mass of 5 kg is released from rest. Okay, so initial speed is 0. On a frictionless surface inclined at an angle of 30 degree to the horizontal, air resistance is negligible. That means acceleration will be 9.81 ms minus 2. How far does the mass travel in a time of 0.8 seconds? Okay. Now please realize that you are on an incline. You are on an incline. If you are on an incline, your acceleration will get divided. Your acceleration will get divided into two components. The vertical acceleration or the acceleration due to gravity is 9.81 ms minus 2. This will get divided into two components. One will be acting downwards like this and one will be perpendicular to the plane. You are not concerned about this green vector. You are not concerned about this green vector. You only need to know this acceleration, this blue one. How can you calculate this? Very easy. 9.81 sine 30. Just as weight used to get divided on an incline, acceleration due to gravity also gets divided on an incline. This is your acceleration. You are starting from rest. You are also given the time. Can you calculate S? Let's write down all the values. U is equals to 0. Acceleration is 9.81 sine 30. And your time is 0.8 seconds. Can you calculate S? Yes, you can do that. How will you do it? S is equals to ut plus half at square. This gets cancelled out, becomes 0 because initial velocity is 0. S is equals to half into acceleration, that is 9.81 sine 30 into what is the time? Time is 0.8 square. Let's calculate it. 9.81 sine of 30 into zero point 0.8 whole square divided by 2. This gives you an answer of 1.56, that is 1.6 meters. This question is 24, and if on the back side you check the answer for 24, it is A. Let's further move ahead. The resultant force acting on an object is slowly increased. Perfect. Which graph shows the variation with time t of the momentum of the object? Perfect. So, can you realize that the gradient of momentum versus time graph is what? Force. Why? Because force is equals to what? Change in momentum over change in time. As the force is gradually increased, what is happening? The gradient will gradually increase. Any answers like that? In A, initially your gradient was vertical, then it came to a lesser value, so A cannot be your answer. Same happened with C. D cannot be your answer because it is a straight line, and gradients in a straight line remain constant. What is the only option? B, and it is correct as well. Initially your gradient is horizontal, then it keeps on increasing. B is your answer. What is this question? 28. If I check on the back side, the answer to 28 is B. Perfect. Let's see this. A resultant force of 10 Newton acts on a body for 2 seconds. Perfect. Which graph shows the variation with time t of the momentum p of the body? Okay. So we know that the gradient of momentum time graph is equals to force. Out of any of these lines, if the gradient of that line is 10 Newton, that will be my answer. But which line has a gradient of 10? We have to see that. If I examine option B, that this has x0, y20, and then x2, y0. This has a gradient of 10, and that will be your force, that is 10 Newton. So B is your answer. The resultant force should be equal to the gradient of one of these graphs. That would be the correct answer. 10 Newton is the resultant force. The gradient of either of these graphs should be 10 Newton. That will be your answer. B is your answer. Let's see this. An elastic collision occurs between two bodies x and y. The mass of body x is m and the mass of body y is 4m. Perfect. Body x travels with a speed v before the collision and a speed 3v over 5 in the opposite direction after collision. Perfect. Body Y is stationary before the collision. Perfect. What is the kinetic energy of body Y after collision? We have to calculate the kinetic energy of body Y after collision. Are we given anything about the collision type? It's an elastic collision. Perfect. If it's an elastic collision, you can apply a simple trick. You can say kinetic energy before collision is equals to kinetic energy after collision. What will be the kinetic energy before collision? 1 upon 2 m v square. And this mass m is moving at a velocity of 0. The kinetic energy before collision due to mass y will be 0. Okay, what is the kinetic energy after collision? 1 upon 2 m into 3v over 5 whole square plus the kinetic energy of y after collision. Perfect. Now, 1 upon 2 mv square is equals to 1 upon 2 m into 9v square divided by 25. Perfect. Take this to the other side. 1 upon 2. 1 upon 2 mvu square is equals to what? 9 mvu square over 50. Subtract it. 1 over 2 minus 9 over 50. The kinetic energy for y will come out to be what? The kinetic energy for y comes out to be what? The kinetic energy for y comes out to be 8 divided by 25 mvu square. You wouldn't find directly this answer because the answer has been the answer has not been converted into simplest form by the examiner. If you examine option C, 8 divided by 25, C is your answer. Let's further move ahead. Okay, let's see this. A single horizontal force F is applied to a block X, which is in contact with a separate block Y as shown. Okay, the blocks remain in contact as they accelerate along a horizontal frictionless surface. A resistance is negligible, X has a greater mass than Y, which statement is correct. Okay. Now, the best way to answer this question or the best way to understand this question is to assign values here. Let's say this is a force of 10 Newton. Let's say this is a mass of 3 kg. And let's say this is a mass of 2 kg. Perfect. If a 10 Newton force is acting on a mass of 5 kg, what will be the total acceleration? The total acceleration is 2. I know the examiner hasn't assigned values here, but I am doing it just so that you know how things work. Now let's break up these blocks. X and Y into separate pieces. Let's say this is X. Let's say this is Y. And let's say a force of 10 Newton is acting here. Now always remember, there will be a force that X applies on Y and there will be a force that Y applies on X. So let's label all of them. This is a force that X applies on Y and this is a force that Y applies on X Fy. Perfect. This is still 3 kg. This is still 2 kg. The system is still same. Hence their acceleration should also be still same. Acceleration should still remain 2. Obviously 2 ms minus 2. I am being lazy and not writing the units. Okay. Can I calculate Fy here? Yes. 10 minus Fy is equals to mass into acceleration. I have just applied F is equals to ma. Resultant force, that is 10 minus Fy, is equals to 3 into 2. Fy comes out to be what? 10 minus 6, that is 4 Newton. Okay. Now, what will be Fx equal to? Very easy. Fx is equals to what? M into acceleration. Your resultant force is Fx. And your mass is 2. Acceleration is 2. Fx is 4 Newton again. What is Fx? Fx is the force that X exerts on Y. Fx is the force that X exerts on Y. And can you realize that this force is less than the initial force F, which was 10 Newton? Any options like that? C is your answer. The force that X exerts on Y is less than F. Simply, I have told you a diagram, numerical diagram as well for this. Let's move on to another question. Let's see this question. A glider of mass 150 kg is launched from rest. Okay, so it's starting from rest on a straight and level track using a catapult. The graph shows the variation with time t of the resultant force. What is the speed of the glider when the resultant force on it reaches 0? Okay, so we have to calculate the speed when resultant force reaches 0. How will we do that? First of all, can you realize that the area under this graph, is equals to what? Change in momentum. This is a force versus time graph. The area under this graph will be change in momentum. So let's calculate that. 1 upon 2 into 10 kilonewton, 10 into 10 raised to the power of 3, multiplied by the time, that is 40 seconds. This comes out to be your change in momentum. This is 1, this is 20, and 200 into 10 raised to the power of 3 is your change in momentum. Okay. Now you are starting from rest, so your initial velocity will be 0. How can you represent the change in momentum? Change in momentum is equals to mass into change in velocity. 200 into 10 raised to the power of 3. What is your mass? 150, 1500. And your change in velocity is what? V minus 0. Your initial velocity is 0. 200 into 10 raised to the power of 3 divided by 1500 is your velocity. What does your velocity come out to be? Let's calculate 200 into 10 raised to the power of 3 divided by 1500. This gives you an answer of what? 133 ms minus 1 is your velocity. The answer to 46 is A. And you can check it on the marking scheme as well. A body experiences varying resultant forces that causes its momentum to vary, as shown in the graph. At which point does the resultant force have the largest value? Can you realize this is a momentum versus time graph? The gradient of momentum time is resultant force. So the point where you have the highest gradient point is your highest resultant force. Which is your highest gradient point? B. B is your answer. Simple. Let's further move. The velocity time graphs of four different objects are shown. Okay. Which graph represents an object falling from rest through a long distance in Earth's atmosphere? Okay. So, what are we talking about? Whenever you have words such as long distance, tall building, we are basically talking about terminal velocity. Which graph shows terminal velocity? Any ideas, geniuses? D graph shows terminal velocity. Simple as that. Let's further move ahead. A stone S and a firm rubber ball R are identical spheres of equal volume. Okay. They are released from rest. Okay. Both of them are starting with a velocity of 0 perfect at time t is equal to 0 and fall vertically through the air. Both reach terminal velocity perfect. Which graph best shows the variation with time t of the speed v of the stone and of the rubber ball? Okay. Basically, we have to tell how the stone and how the rubber ball reaches terminal velocity. Please identify that if there are two balls, one of a stone and one of rubber, both of equal volume, which one will have a greater mass? Which one will have a greater mass? The stone ball will have a greater mass compared to the ball of rubber. If you have a greater mass, you will have a greater weight as well. If you have a greater weight, your weight will equal to air resistance at a greater speed, simply stating that if your mass, if those who want to remember it simply, mass is directly proportional to terminal velocity. The greater the mass, the greater will be your terminal velocity. So B is your answer. Okay, let's see this. The resultant force acting on a raindrop of mass m falling with velocity v is given by this equation. Perfect. Where k is a constant, g is the acceleration of free fall. What is the velocity of the raindrop when it reaches constant terminal velocity? Perfect. So at terminal velocity, your resultant force equals to 0. Resultant force is equals to mg minus kv square. Bring kv square to the other side is equals to mg. V square is equals to mg over k. V is equals to under root mg over k. Any answers like that? C is your answer. Okay, let's see this. A wooden block rests on a rough surface. Okay, so there will be frictional force. One end of the board is released, then raised until the box slides down. Okay, so the box is sliding down. Where will be the frictional force? Frictional force always opposes the motion. So it will act upward up the board. Okay. So A and B will get cancelled out. Perfect. And it is moving at a constant velocity. Whenever you are moving at constant velocity, your resultant force is 0. Which option will be correct? D is the correct answer. Okay, let's see this. The velocity time graph for an object of mass 2.5 kg is shown. Okay, so this is the velocity time graph for an object of mass 2.5 kg. What is the resultant force? How can we calculate the resultant force? Resultant force is equals to ma. What will be your acceleration here? Let's say this is velocity 3. Let's say this is velocity 3 at a time of 0. And let's say this is velocity 12 at a time of 15. So let's create 2 points here. Let's create 2 points here and calculate their gradient. This is x15, y12. This will be x0, y3. Always remember, gradient of velocity time graph is equals to acceleration. Can we calculate the gradient here? y2 minus y1, 12 minus 3. x2 minus x1, 15 minus 0. What will your answer come out to be? 9 divided by 15. Your acceleration is 3 over 5 ms minus 2. What is your mass? 2.5 into 3 over 5. Your answer comes out to be what? Let's calculate it. 2.5 into 2.6. Your answer for resultant force comes out to be 1.5 Newton. Let's see the question number 59. And the marking scheme also justifies our answer. A stone is dropped from a tall building. Perfect. As soon as I see tall covered, I know that this question will be talking about terminal velocity. The next statement proves my suspicion. Air resistance is significant. Perfect. The variation of distance fallen with time is shown by the dash line. Perfect. Okay, the variation of the distance fallen is shown with the dash line. A second stone with the same dimensions but with a smaller mass. Okay. If you have a smaller mass, what will happen? You will reach terminal velocity early, or your terminal velocity will be less. Which line represents the motion of the second stone? Can you tell any line that represents the motion of the second stone? A and B cannot be your answers because you will reach a terminal velocity lesser. So your distance time graph will be less steep. So either D will be your option or C will be your option. D cannot be your option because can you see D is a straight line throughout? No, it cannot be your option. C can be your option because C is initially a curve and then it gets a straight line signifying terminal velocity, and also C is lower than the dotted line. This means your mass is smaller. Perfect. Let me check it. Yeah, in the marking scheme as well, 61 is the answer of C. Okay, let's try this question out. This seems interesting. Okay, so two blocks of mass, capital M and a small m, are joined together by a thin string which passes over a frictionless pulley as shown. Perfect. The acceleration of free fall is g. What is the acceleration A of the two blocks? We have to calculate the acceleration of the two blocks. First of all, this is the tension T. This is the tension T. Perfect. This will be the weight acting downward. This will be what? Capital mg. And this will be the weight acting downward, small mg. Perfect. Can you realize this capital mass will be moving downwards? Yes, sir. This capital mass will be moving downwards. Okay. So if this capital mass is moving downwards, what will be the resultant force? The resultant force is capital mg minus tension. What can this resultant force be equal to? Capital M into the acceleration A is equals to mg minus tension. Let's make tension the subject. Tension is equals to capital mg minus capital ma. This is your equation number 1. Now let's consider the second free body diagram, that is this. Okay. In this, can you realize the small mass m is moving upwards? Perfect. What will your resultant force be? Your resultant force will be tension minus small mg. Your resultant force can be replaced by what? Small ma is equals to tension minus mg. Let's bring mg to the other side. Ma plus mg is equals to your tension. This is your second equation for tension. Can you equate both of them? Yes. Capital M small g minus capital M A is equals to ma plus mg. Perfect. You have to calculate acceleration A of the blocks. So let's isolate all the acceleration variables to one side. Capital Mg minus a small mg is equals to ma plus capital Ma. Perfect. Let's take A as common here and let's take G as common here. Capital M minus a small m, perfect, is equals to A common small m plus capital M. capital M minus a small m divided by m plus capital M multiplied by g is equals to your acceleration. What will your answer be? This is the capital M. Please, please, please. My writing is also becoming really bad. Capital M minus a small m is equals to small m plus capital M. Any answers like that? B is your answer. A stone is projected horizontally in a vacuum and moves along the path shown. Perfect. X is a point, okay, on this path. XY and XH, okay, XY and XH are vertical and horizontal lines respectively. Through X, XT is a tangent to the path at X. Perfect. Along which direction do forces act on the stone at X? Do you remember in projectile motion there was only one force? That was the gravitational force that acts vertically downwards in the direction of xv. Any answers like that? B is your answer. Let's try this out. Two balls P and Q of equal masses move along a straight line directly towards each other as shown. Perfect. Ball P has a velocity of this to the right and ball Q has a velocity of this towards the left. P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after collision? So, if your motion is perfectly elastic, what does this mean? Speed of approach is equals to speed of separation. What will be your speed of approach? Since both velocities are in opposite directions, do you remember how to calculate speed of approach? By adding both the velocities. Now, speed of approach comes out to be what? 1.8 ms minus 1 is your speed of approach. We will select an option in which speed of separation is 1.8. If you analyze option D, this is acting towards the left, this is acting towards the right. Speed of separation, if both velocities are in opposite direction, is what? Adding both the velocities, 1.8 ms minus 1. Let's further move ahead. Okay, let's see this. An object of mass 0.3 kg is traveling in a straight line at a constant velocity of 3 ms minus 1 on a horizontal frictionless surface. Perfect. Object X collides with a stationary object of mass 0.5 kg. Perfect. After the collision, X moves with a velocity of 2 ms minus 1 at an angle of 60 degree. Perfect. Object Y moves with a velocity of v at an angle of 41 degree to the direction of x before the collision as shown. Perfect. What is the value of v? We have to calculate the value of v. How will we do that? How will we do that? This is a basic question of 2D momentum. This is a basic question of 2D momentum. Is there any way we can calculate v? Yes, we can do that. We can consider the vertical plane. We can consider the vertical plane and we can say that the total momentum in vertical plane before collision is equals to the total momentum in vertical plane after collision. In vertical plane after collision. Okay. Now, if you can realize that the velocity in the vertical direction before collision, what is the velocity in the vertical direction before collision? Zero. So the total momentum in the vertical direction before collision will be zero. What will be the total momentum in the vertical plane after collision? So after collision, you have two vertical velocities in the vertical plane. Let me mark those. One velocity is acting like this, and the other velocity is acting like this. First of all, how to calculate these velocities? These velocities are the vertical components of the diagonal velocities. How to calculate these? This velocity v is acting at an angle of 41 degree. Can I calculate the vertical component of this? Yes. V sine 41. And can I calculate the vertical component of this velocity too? Yes. 2 sine 60. Perfect. Now also remember velocity is a vector. So you can mark the axis as upward as positive, downward as negative. Perfect. Okay. Now, can you tell me what will be the vertical momentum of ball Y? What will be the vertical momentum of ball Y after collision? Yes, very easy. Ball Y has a mass of 0.5 kg multiplied by the velocity, that is what? V sine 41. Perfect. Plus, what is the mass of ball X? 0.3 kg multiplied by the velocity of ball X in the vertical direction, that is 2 sine 60. Perfect. Can you calculate this V? Yes. Also, you will be adding a negative sign here. Why? Why will you be adding a negative sign here? Yes, any guesses? Because this velocity is acting in the downward direction and downward vectors are negative. Okay. Let's bring this to the other side towards the left hand side. This will become what? 0.6 sine 60 is equals to 0.5 V sine 41. V comes out to be what? 0.6 sine 60 divided by 0.5 sine 41. Let's calculate it. Let's calculate the answer. Zero point 0.6 sine 60 divided by zero point 0.5 sine 41. Let's calculate this answer. The answer for velocity comes out to be 1.6. Any answers like that? C is your answer. So basically, what have I done? Let me zoom out a bit. Basically, what have I done? I have simplified this question by considering only the vertical plane. And in the vertical plane, I have considered the total momentum before collision and total momentum after collision. Since before collision there are no vertical velocities, the total momentum in the vertical plane will also be zero. And after collision, there are two vertical velocities. These are basically vertical components of the diagonal velocities. One is acting downward, so I have placed a negative sign with it. One is acting upward, so I have placed a positive sign with it. Total momentum before collision, total momentum after collision, your V comes out to be 1.6 ms minus 1. Simple. Okay, let's see this question. The table shows four different collisions between two blocks, each of mass 0.5 kg. Which collision is perfectly elastic? For perfectly elastic collision, I have just told you guys, speed of approach should be equal to speed of separation. What is the speed of approach in A? 4 plus 0, that is 4. Speed of separation, there is no separation. A cannot be your answer. Can you look at B? In B, your speed of approach is what? 2 plus 2. Always remember, if speeds are in opposite directions, you can calculate the speed of approach by adding both the speeds. What is the speed of separation in B? It is 0. So this also cannot be my answer. Let's check out C. In C, what is your speed of approach? 2 plus 1, that is 3. What is the speed of separation? Speed of separation, all the speeds are acting in opposite direction. 2 plus 3, 5 ms minus 1. No, they are also not equal. So C cannot be my answer as well. Let's try out option D. 4 minus 1 is equals to 3 ms minus 1 is equals to your speed of approach. Why have I subtracted it? Because both the speeds are acting in the same direction. Can you calculate the speed of separation as well? Yes, 4 minus 1. Because speeds are acting in the same direction. Speed of separation is equals to speed of approach. D is your answer. Again, let's try this out. Which collision is not elastic? We have to see in which collision speed of approach is not equal to speed of separation. Here, your speed of approach will be what? 4 minus 1, since both of them are in the same direction. What will be the speed of separation here? Since both of them are in the same direction, 5 minus 2, this is 3. So this is elastic, perfect. We have to find a not elastic collision. Okay. So in part B, if you analyze, the speed of approach will be what? 6 minus 3, that is 3 ms minus 1, since both of them are in the same direction. And in part B, speed of separation will be what? 7 minus 4, that is 3 ms minus 1. Perfect. This is also equal to each other. So B is also elastic. This cannot be my option. Let's analyze C. Your speed of approach is what? 8 minus 2, that is 6 ms minus 1. What is your speed of separation? If you focus, 8 minus 5, this is 3 ms minus 1. Your speed of approach is 6. Your speed of separation is 3. They both are not equal to one another. Hence, this is not elastic. C is your answer. This marks the end of the past papers for dynamics and momentums. If you have any questions, you can ask in the chat.